Happy 2019, everyone. Whenever a new year comes around, I find it's always nice to just take that time and reflect on what's happened the last year and what do you kind of want to achieve in the next year. I know it's super stereotypical. One of the things I want to get into for 2019 is running, but with this weather, do you see this? This is just absolutely no fun to run in. So I guess the next best thing is to just go for walks. Fresh air and all that, you get outside and you never know what you're gonna find. What is that? That is a Printrbot Play in the middle of nowhere, printing. How? There's no power out here. Wait a second. That's batteries. That's a whole bunch of batteries, but what's controlling this? How did they start the print? This thing doesn't have an LCD screen. Wait, there's a Wi-Fi access point here called Red Printrbot Play. Does this thing have an access point built in? It does. I'm getting Octoprint here with a mobile interface. That's nice. Well, full disclosure, it was me that put this thing here. I built the Printrbot Play into a mobile 3D printer with a Raspberry Pi in there that gives you Wi-Fi wherever you are. It has batteries for 6 hours of printing at least. And yeah, it's a mobile 3D printer. You can pick it up, you can run around with it. Look at the little guy just happily printing along. So in today's video, I'm going to show you how I built this. But before that, quick shout out to today's sponsor, Skillshare. They're an online learning community for creators with over 25,000 courses on business, creative work, and more. And more of them a bit later in the video. So today we are going to make this Printrbot Play wireless. And I don't just mean, grabbing a Raspberry Pi. Damn, this one is jacked up. I don't just mean grabbing a Raspberry Pi, throwing Octoprint on this, slapping it in here and saying, okay, this is now wireless. No. Completely wireless, off the grid even. So it's gonna get batteries. These are 6 Sony NP-F batteries. It's going to get the Raspberry Pi, of course, but it's gonna be running in access point mode, so you can just grab your phone and connect to it wherever you are. You don't need this thing connected to an access point. This thing is going to be the access point. There's going to be a ton of these DCDC converters in here that just allow the printer to run off of these batteries. These are 7.2 volt batteries. The printer needs 12 volt, so that's going to step it up. I'm also going to keep the original DCDC jack, and I'm going to be able to use the original power supply to recharge all the batteries that are mounted to the printer and to power it off a power supply should I not want to use it with batteries. So there's going to be a bit of tech that goes into it. But first, why did I pick the Printrbot Play? It's like a 2-year-old machine, but there's a few very specific reasons. First of all, this thing is built like a tank. If you've seen my review of it, it can stand on this. It also has this kind of neat-ish carrying beam, I guess, that you can grab. Also, it is compact, which is nice. You can put it in a bag and just carry it around. It has auto bed leveling. And just overall, whenever I pick this machine up, I turn it on, I use any printer profile in the slicer and it just prints, it just works. It also does not have a heated bed. You're probably seeing the blue tape on here, and not having a heated bed actually makes a huge difference in how much power a machine draws. The main power draw for this machine is the hot end, which is probably going to do 10 watts or so. The stepper motors just have their running and holding current, and in combination they're going to consume probably around, 20, 30 watts maybe at most. And if you added a heated bed to that, if you have a regular size 20 by 20 centimeters, 8 by 8 inches heated bed, that would add easily another 70, 80 watts to your power budget. So tripling the power the printer draws while running. So that basically means we can use less batteries. It's still a ton of batteries. These roughly estimated should be enough for 3 to 4 hours of printing, so very usable. You're going to be able to do a few prints on this machine. Of course, depending on how much power the machine will end up drawing and how we can optimize it. I'm thinking turning down the stepper current so it actually consumes less power, but we'll look into that once we're done. So yeah, the Printrbot Play is just a really good choice for converting to battery power. And the good thing is, because it uses this boxy frame, we get tons of opportunities to mount batteries. I could mount them to the front, to the sides. So I've printed these holders, which are the same as on the Bluetooth amp, which you can check out up here somewhere. So same NP-F battery holders. We could put 6 of these on the side of the printer, but because I want this to be a bit more inconspicuous and a bit less bulky, I'm going to put them on the back right here. So 3 on this side and then 3 on the other side. And my thought here is because the batteries do add weight, and if you just pick up the machine right here, it tends to tip forward. So having the weight at the back is going to balance that out, and is hopefully going to make for a more evenly weighted pickup experience. You guys have asked for whiteboard drawings when I try to visualize stuff. What the Printrbot Play right now has, let me see if I can sketch this guy. You get it, that's the printer, right? Basically, in the bottom compartment, it has the 12-volt plug, and that goes to a power supply, which is 12-volt, 5 amp. That is this guy, Printrbot Play, very compact supply, and it goes directly to the main board. You see here, why does this printer need to be red? And that's it. Like, that's the end of the story. But of course, with batteries, this is not going to be enough. We have 6 batteries. Each of these have a positive and negative. So the negative or ground is of course all tied together. We have a power input from the 12-volt 5 amp supply. And the first thing that is going to go into is a DCDC constant current, constant voltage DCDC CCCV controller. And this thing is going to charge the batteries. I don't want to take the batteries out of the printer just to charge them up. Now, all these batteries are going to be in parallel or virtually in parallel. But of course, since these are lithium batteries, you don't just want to short them out like this. You don't just want to, tie them together, because if one of these has slightly less voltage than the other, there's going to be a ton of current flowing from one to the other. It might light the cells on fire or do some other stuff. It's just not good practice. There are specific chips, specific ICs that handle these sort of multi-source scenarios, but I'm cheap and I don't want to make this too complex. So we have diodes, and these will basically just prevent current from flowing the wrong way. These are Schottky diodes, so there's not a ton of drop on these. So each of these batteries is going to get a Schottky diode from the chart. Come on. So basically, when the stock power supply is plugged in, it's going to go to this constant current, constant voltage charger. And this is just going to make sure that none of these batteries ever go above 8.4 volts, which is their fully charged voltage. And it's also going to make sure we're not pushing too much current into each of the batteries. And the battery that is being charged is always going to be the one with the lowest voltage, so the one that needs charging the most. On the other side, we've got the same issue. We don't want to tie these batteries together. We don't want to short them out against each other. So same story here. And they will go into another DC-DC converter. In that case, that is this guy. So that is a boost converter, and this will step up the voltage to 12 volts. So whatever voltage between 6, which is empty for these lithium batteries, and 8.4 volts, which is full, this thing is going to convert to 12 volts, which we can feed into the printer. The nice thing about this specific DC-DC converter is that it has this display built in, which you can use to either display the input voltage from the batteries or the output voltage that you're setting this to. We can also use it as a battery display, so battery status indicator. If the batteries run low, this is going to show us, this is going to display the exact voltage the batteries are at. 12 volts into the printer's going to be happy. That's great, fantastic. Now there's one more thing that we need to take care of, and that is the Raspberry Pi. This thing of course takes 5 volts from the USB port or from one of the GPIOs. You can also feed 5 volts in there. So we will need a separate DC-DC converter to feed that, to give it nice, clean, regulated 5 volts. And for that I'm going to use this tiny guy. That's just a small buck converter, and that will be feeding off the batteries directly as well. And we'll be outputting 5 volts for the Raspberry Pi. And of course, the Raspberry Pi is also going to supply the main board with 5 volts through USB. Now, the diodes I will be using are these smaller SB120. These are 1 amp Schottky diodes. And then these beefier SR540. These are 5 amp diodes on the output here. So in case we just have 2 batteries installed, which is going to be the minimum to provide enough current to supply the entire printer, each of these diodes will need to handle, if this is a 60 watt output, quick math, about 5 amps roughly, not quite, but that is the corner case. So 5 amps at most. So these 1 amp diodes are just not going to be good enough. One more thing we could do here is to add an extra diode over the batteries and the 2 charging and output diodes. The current that we feed in the power supply that's going to be used up by the printer directly will not need to go through 2 diodes. Just a bit of efficiency gain, not a huge deal. So this is how the battery mounts are going to end up on the back of this printer. I need to leave a bit of space between these because back here, out of these two holes, that's where the wires are going to go. And I'm going to lead these into the frame and route them on the inside. But back here, these are going to get mounted to the steel frame. The holes in these brackets are sized for M4, for rather short and stubby screws that I've got. So I'm going to be drilling and tapping the frame itself directly. Perfect. So I do have the option for 4 screws per mount here, but looking at how rigid just a single screw is already, I think I'm just gonna go with 2 per mount. So if you've been paying attention, you will have noticed that these batteries actually fit into the mounts here quite snugly, but there's no electrical contact yet. These are just 3D printed parts. Now these batteries have these jacks in the back here. These 1, 2, one is positive, I believe it's this side, yeah, and one is negative. And these have quite the odd size. They're 2.6 millimeters, but thankfully, 2.6 millimeters is this small connector right here. Apparently this is being used in model trains, and it's kind of like the mini version of your 4 millimeter banana plugs, and these fit in here perfectly. You get the center core, and that fits into these 3D printed sockets perfectly. I've made these 2 boards that house all the diodes, so this entire set of the charge and the output diodes, so that the batteries don't short each other out. These look good, these are going to fit in here perfectly, and when we test these and check from the charge input to the first battery positive, we're at 0.18 volts of drop, that's fine, and from the first battery positive to the output, we're at 0.23 volts, so these are working as intended. Well, that actually looks a surprising lot like it's supposed to be that way, right? It is still front heavy, it is still tipping forward, and it's surprisingly carryable. Like I thought this was gonna be super heavy, but it's not too bad. So now it's time to get all this stuff wired up and everything installed. We're gonna need to get this, these, this, that, and this all crammed into the bottom compartment here somewhere. The idea is to use, well, first of all, to use this 3M VHB tape. This is the tape you're used to seeing from GoPro mounts, and the good thing is this stuff sticks incredibly well. It sticks well to powder-coated surfaces and to PCBs and to anything else basically, and the longer you press it on and the longer it sticks to something, the stronger it gets. So it's not something like the cheap double-sided tape that's just gonna fall off over time. This is the real 3M stuff. This is awesome. And for the PCBs that I am not gonna be able to tape in directly like the Raspberry Pi because it's so uneven on the bottom, I've made these small 3D printed standoffs. As you can see, these have an M3 hole in the center, and then the rest of the part is offset towards one side so that I'm gonna be able to tape these onto the bottom of the printer and use it in a corner like this so that it doesn't stick out further than the size of the PCB I'm mounting. So that's going to be interesting to see where I can fit everything in. Now, one thing with the Printrbot Play in particular is that it has its printer board right at this side, crammed into the edge right here, and it's got the micro USB port coming out the side, and we're going to use this exact port for the Raspberry Pi. So I've thought about how I can do this and how I can handle this, whether I can move the entire board over or, you know, mount it some other way, but there's not really space because there are standoffs built into the bottom of the printer frame and they're going to get into the way. So what I think I'm going to do is I'm just going to flip this thing 180 degrees. The mounting spots are symmetrical, so I can just flip this around. The wires are all long enough and we don't even need the stock power connector to reach onto the board anymore, and then we're just going to see where I can fit everything else in. I think these are going to go here, that's going to go here. So while we get all these bits installed, I want to talk about today's sponsor, Skillshare. Their online classes range from starting a business over video and graphics design to making a decent pizza. Yeah, you heard that right. If you start working out more, you're also going to need some extra nutrition to keep you going. A real self-made pizza is actually a very well-balanced meal, and Nick Anderer shows you how to make one in the Skillshare course, Italian Chef Secrets, How to Make Perfect Thin Crust Pizza. Skillshare is giving away a free 2-month unlimited access trial to the first 500 people who sign up with the link in the description box below, and after that, it's only around $10 a month. It's a new year, so take the next step to stay learning and become a new you. Also, eat less junk food. Unfortunately, I did break the original barrel jack from the Printrbot Play, so I had to replace it with this more robust one, but that fits right in. Okay, so that is basically the input, the charge controller, all the diodes, the batteries, all that stuff is wired up. Now it is starting to turn into a bit of a mess, so I'm gonna finish this bit first and kind of get it into the positions I want it to be in. But before I start wiring up more, before I start adding the DC-DC converters for the Raspberry Pi and for the rest of the printer, I want to adjust this one charge controller. And there are 2 limits that I can set on this one. And I'm gonna show you how to set these constant current, constant voltage modules so that they actually work as a battery charger for these lithium-ion batteries. So these CCCV, so constant current, constant voltage modules, typically have 2 or 3 potentiometers on there. Sometimes they're labeled, sometimes they're not. In this case, this one's labeled CV and this one's labeled CI, so CV, constant voltage, CI, I symbol for current. And if these things have a 3rd potentiometer, that's for like a charge status LED. You can see this has 3 LEDs, and typically they're going to be constant voltage mode, which means the battery is basically at its full voltage, a constant current LED, which means it's charging up to that voltage, and a idle or full indicator that lights up once the current drops below a certain threshold, which means the battery is basically full. Now to set the voltage for this one, it's pretty easy. You just power this thing up. I'm going to plug in the power supply, and then with a multimeter set in the voltage scale and voltage measuring, we can just turn this one until we reach the correct voltage. And with the constant current one, we're going to set the multimeter to current modes, 10 amps in this case, and then we're basically going to short the output through the multimeter, and it's going to limit the current to whatever we set with this potentiometer. So using the original power supply here, this is lighting up because we're in constant voltage. I'm just trying to not short out anything here. And if we actually go out to, well, let's just go directly to the output. Yes, and that is in current mode. You just saw that flip over to red, and if you go back at it, you can see it's red and blue. I'm not sure what each one of those mean, but it's sparking, so it's putting out quite a bit of current. Let's actually switch this back to voltage measuring, and we're not going to get sparks. And we're set to 12 volts, which means this thing is cranked to the max. Here we go, now it's starting to go down. 10, let's go with 8.4. That's all right. Now to switch over to constant current and set the charge current, I think we're just gonna go with like maximum current that we can get, but let's actually verify how much that is. So right now it's 2 amps. Let's crank that up slightly. 3 amps, 4.5, 5 amps, and it's probably gonna, yeah, it's gonna top out, going to internally limit itself. So let's go back a tiny bit and go to 5.0. There we go, 5 amps on the output. So now basically this is an 8.4 volt, 5 amp limited output, which is perfect for charging one of these batteries. These cheap batteries have between 7,500 milliamps or 6,600, so probably realistically they're 5 amp hour batteries, which means if you charge them with 5 amps each, it's 1 C, which is, it's a normal charge current for lithium-ion cells. So if you plug one of these in, it should hopefully not blow up. But since we're using the small diodes for the charger, but I don't want to short it against the motor here, I'm gonna have to plug in all the batteries to actually charge. So we're gonna do that once everything is assembled. The voltage on here is fine, so let's move on. So now in theory, when I plug in a battery, this thing should light up and we should be able to adjust the output voltage that the printer is going to see with this potentiometer. And then I'm going to figure out what these two buttons do. They're labeled in and out, but I don't think that's actually what they do. So we have a ton of different devices drawing power from this one battery power rail. So it just makes more sense to use these connectors instead of soldering stuff together or crimping it into distributor blocks. So let's see what we get. Nothing. Oh, here we go. So one side is not connected apparently. Oh, found it. Pretty easy. The cables for the battery mounts had just pulled out from the screw clamps. I don't know. I feel like they're slightly the wrong size, but these are like the standard blue 5 amp blocks that you can get. I might go back and solder everything if this becomes a problem in the long run, but for now it's fine for testing. It works, and I have, you know, if one of these comes loose, it's redundant. There are 6 batteries. As long as it doesn't short out anything else, it's fine. I'm assuming that is 15.6 volts on the output. That is correct. So let's dial it down. Now the nice thing is, I guess if I do, that's just on off instead of in. If I press this, I can see the voltage that it's getting from the battery. So 7.9 volts. And that can also serve as a battery indicator. Of course, it's on the bottom, so I might think of something else. But for now, that's good enough. We can check just how charged up the batteries are before our printer can lift up the printer and check down here. Let's go to 11.5 volts just to save a bit of power, hopefully, on the hot end. 11.5, so that is correct. Let's go. The Printrbot Play is all wired up. You can see I'm powering it from the power supply, which means it's going through the charge controller. I've readjusted the voltage that goes to the batteries because there is some base load, so there's no risk of overcharging this. Then it's going from the batteries through the boost controllers. It's also going to the Raspberry Pi. I've set it to 5.2 volts, and as you can see, I'm powering that through the GPIOs. I guess I can zoom in right there. You can see it's red and green right there right now, which means it's not booting up, but that's because it just doesn't have an SD card and an operating system in there right now. The board is lighting up. The board is lighting green, so that's getting power. Next up, I'm gonna clean up all this wiring in here, put a few zip ties in. Ultimately, I think I should put some sort of bottom plate on this and just completely cover it up so you don't reach in there and accidentally break something or disconnect something. There is one more thing I want to do to this printer, and that is installing these bumpers. Now I printed 2 of these on the CR10 because these are rather large, and the intent for these is to have them go on the back and on the front, because you can see the bed actually extends past what the frame covers. So if you bump this while it's being carried around, you might bump the print and ruin that. But on the back, as it actually turns out, the batteries are sticking out far enough. You can see it's basically flush with the bed right there. So I don't see that becoming a problem. So this backside is covered, and also I couldn't install this anyways because the battery mounts are in the way. But at the front, this actually makes a ton of sense because this fits right here. And if the bed fully extends, I mean, it's going a bit past it, but how often are you actually using your full build envelope? So I'm just gonna screw this into the original mounting points right there, take out these screws, put in a few longer ones, and we're gonna have this bumper that just keeps the bed safe while printing. All right, looks like it's all coming together pretty nicely. We've got the front bumper here, that's looking nice. So the last thing to do here is to set up Octopi to actually provide the access point functionality so that I can just check this thing anywhere, connect to it with my laptop or with my phone and print from there, so that this doesn't need to be connected to you know, your home Wi-Fi or some other access point. This thing is going to be the access point. So I'm gonna go figure that out right now, and I'm gonna check back with you once it's all done. I did it, it's done, it's running. It was actually quite straightforward to get this all set up, but I don't know. I know how to do most of these things, how to, you know, dig around in Linux and how to configure things, but I never particularly enjoyed it. It always feels so, I don't know, intangible, I guess. So this card has the Octopi installed. That's all set up. I did this on a separate Raspberry Pi so that I wouldn't have to do it in the printer itself. There we go. We're also going to need a Wi-Fi dongle because this is one of the old Raspberry Pis that doesn't have Wi-Fi built in. I think this is a 2+B or model. And now this should just boot up as soon as I give it some power. So let's see what happens. Green. Yes. Getting some blinky lights. Raspberry Pi is booting up. Perfect. So the Wi-Fi dongle is blinking. And there's our red Printrbot Play Wi-Fi network. So I've actually installed a plugin for Octoprint that gives you a more touch-friendly interface. It's pretty rough, but more functional than having the full interface on a tiny screen. But for the initial setup, I'm gonna go with the full browser-based kind of interface, and it all seems to be working really well. The hot end is heating up to temperature quite well. I did have to bump the voltage to 12.5 since the fans were kind of competing too much with the heater in there, but otherwise we can home the entire thing. X, Y, we can home Z, I believe. Yes, that's also working, and it looks like we are ready to print something, so let's do that. All right, let's grab this whistle by Jiziza. Quick new Slicer profile in Slicer Prusa edition. Let's set up Octoprint integration real quick so we can send the files straight to the printer. Check the preview, of course, that looks good. And say send to printer, and it's gonna send it straight to the Printrbot Play. There it is. It's exciting. Yes. G29 auto leveling. That seems to work. All right, and now it's heating up. This is working so well. Okay, right now it's still plugged in, it's still charging up, but we don't need that. So let's drop you into time-lapse mode so you can watch this thing go. There's no wires connected. This is literally wireless. I almost forgot to load some filament there, so I just grabbed the nearest one. So yeah, great success. This print, as always, with the Printrbot Play came up beautifully with almost no tuning, and this is a whistle. It whistles, it works. So the print was about 2 hours of print time, and the batteries are at, let me check, 7.66 volts. And that means these batteries are not even half empty. The voltage isn't really linear on lithium cells, but 7.2 volts is half full. So considering this was a 2-hour print, I'd say the total runtime of this thing is probably somewhere around 6 hours, 7 hours, which is pretty great already. Now, of course, there is still that tuning potential with using dynamic drivers that can run at a lower current and still output the same amount of torque, or just tuning these down. That can be done through Octoprint, through the console, I believe, with the printer board. But yeah, overall, this turned out so nicely. Like, this is such a neat package. You can literally carry this around and have it printing. That is so nice. I'm really happy with the estimated 6 hours of battery life. If we check out the bottom compartment here, I think that even turned out pretty nice and cleanly. Of course, having some sort of a cover here, that's going to be something that I still need to add. I'm probably going to print something that covers this up and leave some room for the cables here. And I will probably want to add some sort of physical button to shut it down, because as is, you can't just grab the batteries, pull these out and power the printer off that way. The Octoprint install is only going to handle that a few times until the Linux system breaks. So right now you have to go into the menu here, go system, shutdown system. Yes, and then the Raspberry Pi will actually power down, and you can then take out the batteries. So that's still a bit tedious, but it's not that big of a deal, and the Wi-Fi connectivity is actually working really nicely as well. Thankfully, with a system like the Raspberry Pi and the Raspbian, Debian, Linux running on there, there's a tutorial for pretty much everything out there already, and that just makes working with a Raspberry Pi so nice. If I do take this printer to MERF 2019 at the end of March, I'm probably still going to replace the spool mount and print a separate piece that also acts as a handle. This bench sheet metal one, I don't know how long that's going to last, but overall, yeah, this is nice. I like it a lot. It's probably going to be my standby printer. The printer that's just always there, connected through Wi-Fi, ready to go, ready for me to send off a single print. Now, of course, I don't want to connect to the printer's Wi-Fi every single time because this is in the basement, and if I'm upstairs, I'm not going to be within range of that Wi-Fi. So what you can still do, thankfully, is you can still connect to, where is it? Back here. It's a bit hidden away in the very back here, but you can still plug an Ethernet cord into the jack of the Raspberry Pi, and you get the normal Octoprint web interface through that as well. So you can access Octoprint both ways, through the Wi-Fi that the printer is providing, through the access point that's creating, and through connecting it to your home network and just opening up octopi.local through that. So that is very, very nice indeed. I like it. So if you want to build something like this, I've dropped all the instructions I used for setting up the Raspberry Pi in the video description below. I'm also linking all the components that I've used, the buck boost converters, charge controller, the batteries. I'll also be providing the STLs for these battery mounts and links for the 2.6mm connectors that I'm using. Those are from a German store, but I'm sure you can get those internationally. I really like these Sony NP-F style batteries. They don't look as dangerous as a lithium polymer RC car battery can, so taking this on an airplane is probably not going to be that much of an issue. So, as always, thank you for watching. If you enjoyed the video, give it a thumbs up, get subscribed for more like it, and if you want to support the channel directly, check out Patreon or the YouTube memberships. The YouTube membership is basically the same thing as the $5 Patreon tier. There's never going to be videos behind a paywall. As long as I can make it happen, all my videos will always be freely accessible for everyone. So supporting the channel through Patreon or the YouTube memberships is purely optional. I'm never going to force that onto anyone. If you do choose to do that, thank you very much for that. And yeah, I will see you all in the next one.